Okay, hello, and thank you so much for joining me today at the virtual MENA Information Security Conference. My name is Spitz, and I work in the sales engineering team at Splunk. I'm with you today to share with you Splunk's vision for the future of data, and more specifically, how organizations can leverage artificial intelligence and machine learning as part of their daily security operations. At Splunk, we have an overarching mission, not just to help you see the data in your organization, but more importantly, to turn it into business outcomes. In our particular case, reducing attacker dwell time by speeding up security investigations, detection, and remediation. Before we begin, I just wanted to quickly note that while I may talk about products and features that may become available in the future, you should base any decisions on the most current available technology. All right, with the formalities out of the way, let's get started. In the presentation today, I will cover this concept of the data age and how it relates to the connected world in which we live. I will then briefly describe to you Splunk's Data to Everything platform. This is the foundation upon which we deliver all of our capabilities which we bring to market. Finally, we will deep dive into how you can leverage Splunk's native ML functionality to improve your threat detection capabilities. Okay, so the data age. As you might have heard in some of the other presentations, our world is in the midst of a massive transformation. Technology is refactoring entire industries, globalizing our businesses, and multiplying the efficiency of our workforce. While this is a time of uncertainty, we believe that by building a more interconnected, digitized world, we will continue to improve all of our lives in the long term. The emergence of new technology is what makes that possible, from the transition to cloud computing, IoT, artificial intelligence, machine learning. They all make a contribution to digital transformation. For the first time, we are starting to see a larger transformation taking shape, one that enables companies to unlock meaningful insights and take purposeful action on the data our digital world is creating. There is no doubt that digital transformation is accelerating. Emerging technologies, led in part by the technologies you see on screen, are maturing. Services are going online faster than ever before, and in recent months, the COVID-19 pandemic forced a substantial share of the world's workforce to shift to remote work. All of these societal changes, combined with 2 decades of digital transformation and the promise of transformational technologies, are culminating in this data age. Splunk recently conducted a worldwide survey of 2,000 plus organizations, and the main findings of this research tells us that 86% of organizations are not ready for the coming data wave, so for this mass amounts of data that's going to be created by this technology infrastructure. I don't have too much time to go into this, so for further detail on this research and in-depth findings, please head over to our website, splunk.com, to grab a copy of this report. So in this new world where data will change everything, we all know that as a commodity, data is more valuable than oil. There is no part of our lives that won't be touched by data. Our personal lives are being transformed, and our workspaces will certainly be transformed as well. For example, in media, traditional modes of content creation and presentation have totally changed by the likes of Netflix and Amazon Prime, which rely upon real-time data to understand our interests to shape the content that they create and deliver to us. Financial services have always been at the forefront of adopting data, but recently they're using it to make retail banking more personalized, and they also enable financial services companies to detect and prevent crimes like fraud faster than ever before, with much higher detection rates than seen in previous years. Public sector data is enabling government agencies to make more confident decisions and take decisive actions quicker than ever before. as evidenced by COVID-19 and government response to that. But more specifically, in Dubai, we have something known as the happiness agenda, which pursues an objective, scientific approach to influencing happiness for the whole city of Dubai. With a dedicated focus to measuring people's happiness, the teams continually research and refine a scientific model for city happiness that ultimately is being informed by city data. They have developed a live targeted measurement tool to monitor satisfaction and happiness levels for the whole city and all of the services we consume. Big data insights are not just limited to the technology sector, though. By implementing customer satisfaction and sentiment analysis tools for the whole city, the happiness agenda will empower the government to act for people's happiness in real time, supported by data. There is no way that any part of our lives will be separated from data in the coming years. So, if this is the new reality, why are more people or organizations not doing this? Or if they are doing this, why are they not successful then? Why are we not hearing more success stories like this? It all comes down to the fact that turning real-time data into action is hard. It's actually very hard. Organizations are spending millions upon millions of dollars and countless hours to try and tap the value of this data, this unstructured data, to solve critical business problems. They're creating data lakes, integrating and working across countless systems that create massive data volumes while navigating complex tools designed to aggregate, monitor, and analyze this data. The solution that's been offered to us is, let's structure our data and we'll answer the question. But structuring your data is not a way to get out of this problem. With massive budgets and integration tools, process maps, database experts, data experts, it's increasingly difficult to make headway. This is precisely why so many of the promises of big data have not been realized to date. This is where Splunk comes in. As the world's first data to everything platform, Splunk is designed to remove the barriers between data and action so that people like us, security analysts, and businesses can turn data into doing in real time. And when we say everything, we mean everything. We're here to bring data to every question, decision, and action. We have an incredibly rich knowledge base in cybersecurity, but our platform has grown to include an expanded set of capabilities in IT, in application development, in business use cases. Our customers are coming to us with use cases that we could have never dreamed of. That's the power of Splunk. Let's take a quick look at how we enable this. So, how do we bring data to everything? We believe that every company needs to set up their organization to do three things. One, seamlessly move from what we call investigation to action. Blend traditional approaches with emerging technologies to build for the data age. And finally, to empower everyone in the organization to harness the power of this data. There's no benefit or there's no use of having these complex technologies, ingesting all of this data, doing all of these analytics, if you need a PhD to use the platform, right? It doesn't make sense. So how do you empower people? How do you bring this data, these insights to them so that they can benefit from it? Let's start with investigation to action and how Splunk facilitates that. Okay, so Splunk was founded on a very simple premise. Investigations need to be fast and flexible. Something structured data stores are not built for. If you've heard of Splunk, you probably know of us as the world's best investigative tool. That's because our investigative approach is what sets us apart from every other technology on the market. We were born out of the idea that IT and security should be able to investigate their unstructured data to identify and solve issues. Organizations can send us unstructured data from all of the systems, devices, transactions, applications within their organization. Our unique architecture of the platform means we do not structure that data. We're not managing a data lake We're not managing a database in the backend. We have a completely flexible investigation lake that's ready to react to your needs. It's a fundamentally different approach than every other offering on the market, and it's what makes our investigative lake so powerful. We allow organizations to ask one question, which leads to a next question, which leads to another question, until you finally get the answers that you need. That's typically how security investigations start. You begin with um, investigating some C2 traffic to figuring out, okay, how many other machines are infected? What on these machines is causing that? What are the persistence mechanisms? So forth, so forth. By centralizing all of this unstructured data into one platform, we allow you to quickly react and answer all of these different questions. This is what makes us a leader in investigations, because we can adapt to changing situations, deal with massive volumes of real-time data, and most importantly, get you up and running incredibly quickly. I would like you to take away a few key things from this slide. One is investigation is at the core of our platform. So if you have use cases such as threat hunting, for example, that's precisely what Splunk was built to address. Second, you can send us all kinds of unstructured data, ask us all kinds of questions without a need to structure your data. You can do something as simple as kind of like Google searching for your data. You can talk to Splunk and ask it questions. And finally, our approach means you do not need to structure your data before you ask it questions. So to put it in the context of a SIM, a technology hopefully you're all familiar with, we do not require you to have a log parser to be able to send us data from a system. So in a SIM, if I wanted to send data from a custom application, an in-house application, the vendor would need to build a parser to understand what that data looks like, some kind of integration mechanism to bring that data into the platform, and then build the use cases on top of that. With Splunk, you can use one of the countless methods we have to bring data into the platform without a parser. There's no need. We accept any form of unstructured machine data. And then once you get the data in, you can ask different questions of it and structure it if you wish. As companies have evolved, so have we. We guide our customers on a complete data journey. So, and every company is on a journey, which actually not just includes investigating and monitoring, but has evolved to require analysis and action. Every data problem requires a combination of these four key skills or capabilities: investigation, monitoring, analyze, and then act, whether it's done by a human or by the machine itself. Today, most companies have multiple tools in each of these steps running across their organization. Security tools are implemented separately from IT and within each department. You might find specific tools for specific use cases. Each may seem like the best choice for that individual job, but they're keeping you from realizing the power of all four tenants working together. At Splunk, we're here to guide you on this data journey. In addition to the knowledge and expertise, we're investing in tools at each stage of this journey. Our acquisitions of companies like SignalFX for real-time monitoring, for APM use cases, VictorOps for IT analysis and incident response, Phantom for security automation and orchestration, they allow us the ability to go beyond investigating and monitoring to analysis and action. This framework that you see on screen, investigate, monitor, analyze, and act, can apply to nearly every data problem in your business, especially the core business functions that have digitized the fastest, like IT security, for example. The opportunity to share this data across these different capabilities creates a cumulative effect and an opportunity which every function can drive business outcomes fast. Okay, so bringing data to everything requires more than just preparing for the data challenges. It also means preparing for the needs and challenges of tomorrow. Every organization needs to build for and prepare for this data age. At Splunk, we have a platform for the data age. The next wave of data challenges aren't going to resemble the ones we faced in the past. And neither are the technologies we'll all need to face them. So in the context of security, just bringing in logs and having parsers That's all well and good, but we are moving to a world of cloud, multi-cloud, uh, hybrid environments. So bringing data from on-prem cloud environments directly from SaaS services, lots of unstructured data in all of these different environments uh, that need to go into some form of big data repository, which is what Splunk is. At Splunk, we've been evolving our technologies to prepare for this changing landscape. We've used our size and scale to build new products in-house, buy new capabilities, and invest in an ecosystem of emerging data technology. Over the past few years, we've been expanding our platform at a rapid pace. The scalable index, which is what you see on screen, sits at the core of our offering, and it has continued to anchor our platform. We've been focused on making it easier to get data into that index and making sense of it. We've also launched a set of streaming capabilities with data streaming processor bolstered by in-house development and acquisitions, which allow our customers to analyze and push streaming data to Splunk and non-Splunk data sources and investigate and analyze and apply machine learning to that streaming data in real time before it ever hits a disk. Our bias for action means continued investment in automation and AI, bringing capabilities from acquisitions such as Phantom to our entire portfolio and offering machine learning to all kinds of organizations. We've also been investigating in federated search capabilities. As we mentioned, organizations are setting up these data lakes. So how can you use Splunk to, say, for example, query data that resides in a Hadoop store, for example? Federated search, being able to weave together insights from massive data sets in multiple repositories, both structured databases and unstructured. So the data age requires a rethinking of the technology that's needed. New capabilities around streaming, automation, and federation is what helps us prepare for the data age, and it's specifically what Splunk has been focused and investing in. Last but not least, we help you empower everyone across your business to drive business outcomes. How do we do that? So we have Splunk experts around the world that are here to support you. That includes the 3,000 plus applications available on Splunk Base to help you manage all the different types of data, to the 2,000 plus partners who are here to help you implement Splunk or build custom industry solutions. It also includes our welcoming community of Splunk experts and Splunk Trust with 125 user groups around the world and over 100,000 questions answered on our community-driven Splunk Answers platform. If you have a question, it's most likely answered on our Answers platform. So we have a massive ecosystem to help new customers and existing customers adopt and realize the value from Splunk. Moreover, I spoke to you about bringing data to users. So Splunk Connected Experiences is all about empowering users everywhere, bringing the data to the user. So Splunk Mobile helps you analyze data and receive actionable alerts via push notification on mobile-friendly dashboards while you're on the go. Splunk TV allows you to view dashboards with rich detail in NOC and SOC environments. Splunk Natural Language Platform or Natural Language Processing allows you to use Splunk Mobile and Splunk TV to talk to Splunk. So to ask questions of Splunk, such as how many security incidents have I had in the last week? How many malware infections have I had in the last week? That gets translated into a query in the backend, which is run in Splunk, and the results are presented to the user. Splunk Augmented Reality and Virtual Reality helps our users interact with data right where it's at. Alternatively, interact with systems and data in a different way using, 3D spatial experience, for example. So all of these advances that we have are all around helping users consume the data that Splunk generates and take action against that as well. So if I have a security alert that's triggered, for example, I may have my automation platform take some investigation actions automatically. So, say for example, I have an alert for some potential command and control traffic. So the automation platform would go and say, okay, so how many devices are talking to that domain? What are the users that are impacted? What are the profiles of those users? Are they normal accounts? Are they domain admin accounts, for example? Where are these files, or these processes that are generating this communication? Where else am I seeing them inside my environment? Doing all of these investigation steps automatically for you, and then presenting you on your mobile with all of this information to say, do you want to block this, yes or no? You click block, and it then goes and executes an action across all of your security controls to mitigate that threat, all done from your mobile device. Okay, so now that you understand the value of Splunk's Data to Everything platform, let's take a deep dive into the machine learning capabilities that Splunk provides and how it can help you detect and remediate threats quicker. Just before we get to that, I wanted to summarize what are the key drivers for ML in security. I think we know this, right? But I'm going to summarize it. Organizing, analyzing, and utilizing huge amounts of data. So it's difficult for humans to, say, for example, sift through terabytes and terabytes worth of data per day, trying to find a needle in the haystack or some attacker footprints in that data. It's much easier for the machine to do that. Advanced dynamic baselining for your specific organization. So trying to baseline normal activity, say, for example, web activity for an organization, difficult for humans to do, easy for a machine to do. So to create baseline for user web traffic, what's normal, what's not normal. That's a key use case, or quite a common use case for security. Once you've baselined your users and your device activity, discover anomaly patterns in that data that are not obvious to humans, because it could really be that needle in the haystack that may pass us by. And then finally, reduce the reliance on fragile explicit detection rules. So we all know this, correlation rules, signatures, whatever they may be, they miss things, which ultimately lead to compromises, which ultimately lead to breaches. And that's happening all over the world, despite all of the investments in security operations. So part of the problem is the rules. Part of the problem is this huge amount of data. Part of the problem is these needles that are bypassing the humans. So this is really where machine learning comes into play, because of this big data that's now available to these algorithms to do its analysis. Okay, so an overview of machine learning at Splunk. Where is it? So we have machine learning embedded inside our platform. It's the core. It resides inside the core of our platform. So our core platform search allows you to do advanced analytics, data exploratory, data mining. You can then take the results of that and pass them into certain algorithms to predict something. For example, let's take a more business example, predict how many purchases are going to happen in the next 2 hours on my e-commerce platform, or predict the volume of people that are going to log into my mobile banking service. Because if you have an auto-scaling environment, or if you don't have an auto-scaling environment, more specifically, you can move to an auto-scaling environment, which will grow as the amount of users on your platform increases. Another place where we have machine learning in Splunk is natively inside our packaged premium solution. So we have applications that are sold on top of our big data platform, which have ML inside them, which solve specific use cases, which I'm going to go through. And then finally, we have the machine learning toolkit, which is effectively a workbench which provides you the ability to develop your own ML models for your specific use cases. This is what it looks like from a technology point of view. So I mentioned there is core ML capability within Splunk. It's extended by the machine learning toolkit, which is an application that's deployed on top of Splunk. This machine learning toolkit, for example, is a free application that is available to any Splunk customers. And then we have premium applications or paid for applications which have ML within them as well. So we have Splunk Enterprise Security, which is our analytics-driven SIM solution. And then we have Splunk User Behavior Analytics, which is our dedicated UBA platform. So we have UBA in our SIM, but we have UBA in a standalone platform as well, and I'll explain what the difference is. So let's start with User Behavior Analytics. Splunk UBA is a black box, unsupervised machine learning platform. It provides a number of out-of-the-box models to help detect anomalies and threats within your environment. It does this by bringing in data from the Splunk platform and generating anomalies. From these anomalies, we model patterns of behaviors and join these anomalies together to detect potential threats. These threats are then subsequently integrated into Splunk Enterprise or Enterprise Security. So from a flow point of view, this is what it looks like. You have all of these logs that resides within your SIM. Splunk UBA will query all of these logs and pass them through machine learning models. I have a sample list of models available in the upcoming slides. These models will generate detections which are grouped into anomalies. So, we have 60 plus anomaly classifications, but more than 160 or so detections. Once the platform detects anomalies, we then run additional ML algorithms on top of that to group these anomalies into threats. So there is a threat that there is lateral movement occurring within the environment, but that lateral movement threat could be comprised of multiple anomalies. An anomaly, could have been this machine is, scanning, say for example, running a scan across the environment, or this machine is trying to access 50 machines that it doesn't normally access. This machine, or this user account from this machine has subsequently then logged on to one of the machines that it discovered as part of that scan. So there would have been multiple anomalies, the scanning for detection of other machines on a subnet or shares or whatever, and then the actual act of logging in or getting access to it. So those anomalies would have been combined together to create something known as a lateral movement threat, for example, or any of these other things that you see on screen. So one thing to note is anomalies themselves are facts. Something has happened that is not normal. A lot of people would say that, okay, that's great, but this is a false positive. It actually is a true positive for your environment, but it is not applicable because this anomaly is not considered a threat for you. It could be considered a threat for someone else, for example. So that's one very key thing to note about UBA platforms. They generate anomalies, which are just abnormal things that don't usually happen. They're happening, and I'm going to generate an anomaly. But the problem with that approach is you just get inundated with lots of anomalies. This is why you need this additional layer here of post-processing, really, of being able to see these anomalies, try and stitch them together into threats so that an analyst is not spending time investigating every single anomaly, or me logging in, say for example at 3 a.m. in the morning because I couldn't go to sleep. Okay, so a little bit more detail as to how it works. We have events, aggregated or raw events from Splunk that come into Splunk UBA. They feed 60 plus batch ML models and 15 plus streaming models. So the difference is in the name itself. Batch models run on a schedule, streaming models are running continuously in memory. Data is passed into these models and analyzed as per the baseline. So when deviations from baseline happen for whatever the use case might be, a detection or an anomaly is created. Moreover, the entity and the user is also scored. So there, the platform is continuously maintaining a risk score of a device and a user, and also applications within an environment. So you have multiple ways to use this data, not just looking for anomalies and threats, but also, okay, show me the most riskiest users in my organization for the past 1 day or the past 1 week. I mentioned that we then take those anomalies, run them through some additional analysis or some additional ML models. Here are some examples of them: graph analysis, kill chain analysis. So kill chain is where we try to plot anomalies onto the kill chain. So some reconnaissance followed by exploitation, followed by lateral movement, followed by C2, for example. So we'll basically try and map those anomalies to the kill chain. And we have some other specialized threat models as well, like lateral movement and things like that, which then create 20 plus threat types or threat categories, which the analyst uses for investigation. Let's take an example. So we have, I mentioned we have data that's being analyzed. So data that resides within Splunk, all of your logs from all of your different systems. That's brought into the platform. We baseline users, devices, and also application. And importantly, we're not just taking the example of users. We are not just baselining my activity, for example. It's also baselining my activity, the department activity, the region activity, and the overall company activity. So if my activity is abnormal, okay, that's fine. But my activity is abnormal, but is normal for the rest of the department, then the platform would not generate an anomaly. But if my activity is abnormal for my department and abnormal for the entire country, or sorry, company, then that's definitely something weird is going on there. And the platform would generate an anomaly, which would then, through some additional ML, be created into a threat. Here are some examples here: data exfiltration by suspicious user or device, potential malware, potential compromised accounts within the environments. We assign scores to all of these things, which give me like a likelihood or a confidence score to a threat, which an analyst would then go in and investigate and see, okay, so the platform provides statistics and all of the reasoning behind why it's detecting this anomaly. It will give you scientific evidence behind that, and also show you the fact that this is not in line with normal behavior for this user, region, or company. Going into a little bit more detail using an example. So we have 61 batch and 16 streaming models available within the platform, and they span across behavior and anomaly models, threat models, and so forth. But let's take an example of a batch model, one for anomaly detection, which is unusual Windows security events sequences model. It uses something known as PSTs, probabilistic suffix trees. I won't go into the science behind it. We do actually publish some information about some of the algorithms that we use. But basically, they're a high-scale version of something known as Markov chains, which allow us to determine one sequence of events. Think of it like we're building a chain or a tree. So Denver logs in, Denver requests some info, Denver logs out. That's normal. Adding in another event to that chain, Denver creates a domain admin account would be abnormal because it's not something I normally do. Or requesting information after I log out is also abnormal because the order is wrong. It doesn't line with the chain. Here's an example here where you have this user, they request a Kerberos ticket, their account was logged on, their successful access, followed by some form of change taking place. So this user would never do something like that. These four things here are what they would normally do. So this rare event showing up in this tree, based obviously on thresholds and things like that, is not normal for this user. And then this would be compared, as I mentioned, to the department and the region and the company to see, is this, okay, this might not be normal for Jake, but is it normal for other members in the engineering team of which he is part? If so, maybe it's not, maybe I will not create an anomaly. If it is abnormal, then yes, create an anomaly. So here's one example of one of the ML models available within the platform, the unusual Windows security events. Taking a step back to try and answer, what other models are available within the platform, it actually all stems from the data that is sent to the platform. So Splunk UBA supports all of these data source categories you see here on the left. So authentication data, database, DHCP, DNS, email, firewall, AD, IDS, IPS. This is the entire list. It doesn't mean that we don't support data sources that are not on this list. We do ingest unsupported data sources. It's just a different procedure for doing so. The items you're seeing in bold are mandatory data sources for Splunk UBA. So you need authentication, DHCP, DNS, firewall, and web proxy data. These core data sets are required for the platform to function. So if you do have these data sets going to Splunk or your SIM, Splunk UBA is a good fit. If you have all of these data sources, it's an even better fit. Here are some examples of the kinds of technologies for these different categories. And this is important to note because when we say authentication data, we don't just mean like your domain controller authentication, your Active Directory logs. We mean any form of authentication data because we normalize the data. Here's an example. So here is an authentication data source mapping. So we have a data source, authentication, which is mapped to a set of machine learning models, which you're seeing here in the middle, which is then mapped to the anomalies that are created by these models. So the authentication data could be coming from my firewall. I could be authenticating to a firewall. Denver is someone in HR, and he is authenticating to a firewall. That should never happen. Something is wrong here. So a very simple example, but one that hopefully it's simple to understand and you can relate to. But we look at authentication data no matter where it's coming from, whether it's your firewall, your Unix servers, your multi-factor authentication, your SSL VPN, your Windows, whatever it may be. And we normalize all of this data to our authentication data model so that all of these modules available here in the solution, this is not a full list, there are more down below. All of these models can work irrespective of the device. So you don't need device parsers. You don't need a parser for Cisco ASA, for example, because Splunk is taking care of understanding and normalizing Cisco ASA or Fortinet or whatever other firewall you may have. So here's an example of authentication data. Let's look at an example of proxy data. So proxies you can have reverse proxies, which can reverse proxy all requests going to your web tiers, your web farm. And you can have forward proxies, a choke point where all of the users in your organization go through to get out to the internet. So the HTTP or the proxy, the ML models or the models which use proxy data support both forms of proxies. So we normalize it into this category called HTTP. And then all of these models here would use that data. So malware communication model would use HTTP data. It uses DNS data firewall as well. Beacon assessment. So, potential beaconing activity taking place over HTTP or HTTPS. Browser exploitation, a very interesting model. So you hit a site which has some kind of embedded iframe which is delivering an exploit to your browser, to I don't know, exploit the browser itself or one of the browser plugins you may have, like Java or Adobe or something like that. It's looking at all of these proxy events to determine is any malicious payload being delivered to the user's browser. A web shell model. Obviously, this one makes makes use of reverse proxy data. So if I do have a web shell, a backdoor on my web servers, on my public facing assets, this model would use the reverse proxy data to understand normal activity against my web farm to say to me, this file that resides on your web server, this ASPX file, for example, on an IIS web server, this is potentially a web shell, is potentially malicious. So that, say, for example, would create this anomaly saying there is potential web shell activity taking place on your web farm. So that's how the platform works. You have data, which comes from Splunk. It's fed into these batch and streaming models, which generate anomalies, which then subsequently generate threats, which the analysts investigate. You can also, in the same way you use your SIM for threat hunting, you can use the UBA platform for threat hunting and hunt across your anomalies as well. So that's another use case. Talking about SIM, let's move on to enterprise security and some of the machine learning functionality that we provide within our SIM natively. So I mentioned that we have UBA as a standalone kind of product, and we also have UBA natively built inside our SIM. So what's the difference between the two? So as of Splunk Enterprise Security 6.x, we have introduced the machine learning toolkit into our SIM. And the MLTK is used in provided default searches, correlation searches, key indicators, and rules. So what we do is effectively, we build machine learning baselines for most security activities. So stuff you're seeing on screen here, like building baselines for authentication, for changes, for malware, infection, for email activity, for DNS activity, that kind of stuff. And then we have detections on top of that. So once the baseline is built, any deviation from that baseline trigger an alert. Over here, you're seeing an example of the algorithm which is being used for as part of these models. Density function is a very popular algorithm used for anomaly detection, works extremely well, and one that's used heavily throughout the machine learning toolkit, specifically for security use cases. Moreover, we provide content or up-to-date content to our customers with something known as ES content updates. It's effectively an application which is allowing our security research team to publish content to our customers. We do this in the form of what we call high-quality analytics stories, which are composed effectively of searches and detections in the backend. So let's take an example here of baseline of command line length. So this model will baseline or create a baseline of normal command line length or command line activity. So now, you start seeing some encoded PowerShell activity taking place, which obviously results in a very long command line. This rule down here, unusually long command line, would trigger that because it is not in line with the baseline. So my user or my device, normally doesn't execute PowerShell at all, or even if I do, I use it for some administrative activities. And now all of a sudden, I have these long encoded PowerShell strings and commands appearing. So this would detect something like that. Similarly here for this example you're seeing on screen, baselining DNS query length, and then alerting when there is an outlier. So this comes down to, DNS exfiltration. So say, for example, using DNS text records for command and control. So this model and these rules would help detect that kind of activity within your environment. Moving on to the Splunk Machine Learning Toolkit, which actually is what provides all of this functionality to enterprise security. It extends Splunk, and what we say when we say operationalize machine learning, we mean apply machine learning to your data. So this machine learning toolkit allows you to apply machine learning or these algorithms to your data. And we say it's built for the citizen data scientist. So, you know, you or I can go and build a model. We have videos on YouTube which actually walk you through it, how you can take your proxy data, for example, and build a model to, that is baselining normal user agents and then alerting for abnormal user agents seen right within the environment. So that's something you can go and do yourselves. We actually provide a framework. It's an experiment interface. You can kind of see it here on screen. It provides guided model building, testing, and deployment using 80 plus algorithms available out of the box. These algorithms have specifically been selected by our data science team because they are the ones that are most applicable to the kinds of data you would send to Splunk. So, machine data, your logs from all of your different systems, these algorithms work really well against those data sets. But if you did want to bring in additional algorithms, for example, you can use the API. You also have access to the Python for Scientific Computing library, which allows you access to all the open source algorithms. If you really wanted to take it one step further, you could even use our deep learning toolkit, which supports neural networks and GPU accelerated machine learning. It's like an extension of the machine learning toolkit. Okay, so let me show you what a sample security use case looks like. I filtered, this is the machine learning toolkit app where I have selected within the platform to show me security examples. So here, for example, if I was to click on predict VPN usage, this would take me through to an example of how to use VPN data to predict VPN usage. And if you wanted to now alert for anomalous VPN usage, you could do that as a result of building that model. This is an interesting one, predict the presence of malware, which uses firewall traffic to make a judgment as to is this particular traffic or is this particular network communication malicious or suspicious in any way. We've actually got an application on our App Store, Splunk base, where one of our data science team members has actually built an app called the botnet app for Splunk, where they have taken NetFlow data and they use it to predict the presence of malware. So, potential malware or a bot on a machine initiating, C2 traffic. So check out that application. It walks you through the process of how to use NetFlow data for, detecting malicious or suspicious network communication. And here are some other examples as well on the screen. If you head over to our .conf, which is the Splunk conference that we run annually, we actually have more than 1,000 presentations available online, and they're all split. So if you were to, we only care about cybersecurity, so we select security, and we can see all of the presentations that have been presented over the years. And it's basically a showcase of our customers speaking at our conference, saying how they use Splunk to, say, for example, to do threat hunting, or how they use Splunk and map all of their detections to the MITRE ATT&CK framework, or how do they use the machine learning capabilities within Splunk to detect advanced attackers. So all of these presentations are available on there. I would highly recommend you go check it out. We actually have our conference happening at the end of October. So if you head over to the website and you are free, I would highly recommend you register and attend. There are some amazing sessions that have been planned for this year. Again, people showcasing, organizations showcasing how they use Splunk to fulfill their cybersecurity and their security operations requirements. Here are a few you're seeing on screen here, how Saudi Aramco, how operational technology monitoring for them works well with the Splunk Machine Learning Toolkit and how they use MLTK against their OT data. Here's another one from Lockheed Martin, another one from Siemens, where they're augmenting their normal security use cases and their correlation rules with use cases that they've built with the machine learning toolkit. So they've actually built some models which analyze proxy data, for example, to find anomalous proxy requests based on multiple features or parameters. And they've also built one for analyzing command line execution to understand what anomalous command line execution is happening within the environment. I'd highly recommend checking them out. These presentations are available at this website here, conf.splunk.com. Okay, so to wrap up, Splunk Enterprise Security, our SIM, and our UBA, our unsupervised machine learning platform, they both work well together. So Splunk providing the log aggregation rule statistics correlation driven by humans and the SOC analysts, and Splunk UBA on the other hand, which is a totally unsupervised black box solution, which is continuously profiling your users and devices and scoring them and discovering anomalies within your environment. Both of these approaches work well together because using Splunk Enterprise Security for typical security monitoring use cases or threat hunting, this is stuff that humans are very, very good at. But when it comes to analyzing tons and tons of data and what's normal versus what's not normal for this user or this device, that's where kind of Splunk UBA comes in with its machine learning to generate these anomalies and these threats to provide this unified view for the analyst to conduct their investigations and take some action. Okay, so to summarize, I think it's fair to say that this data age is just beginning. We are kind of at the forefront of it now, and there are a lot of organizations in the position that you might be in, which is not entirely sure of how you're going to deal with this this data. So companies like Splunk are here to help and facilitate you on this journey. And we do understand that each journey is unique. So we actually offer something known as a prescriptive value path exercise, where we look at your maturity in terms of, say, for example, security monitoring, advanced threat detection, automation, machine learning. And we build this report for you to say, okay, this is where you're at. And if this is where you need to get to, these are the things you need to do with associated timelines against it. This is typically an exercise that lasts a few hours. It's entirely complimentary. It's done by the engineering team, people like myself. If it's something you're interested in, here in the chat, or we have some other Splunk representatives on the conference as well. Please reach out to us. I'd like to take this opportunity to thank you for spending this time with me, for listening to me. I hope you found this session informative, and sincerely, thank you for your time.